All right, guys, we are moving on to section 3 of our Earth's internal processes chapter. Last week we talked about seismic waves and we focused on the P waves, the S waves, and the surface waves. We talked about their motion and we also talked about what states of matter that those different waves are able to move through. And that is all going to become very important as we go through this section because those seismic waves become very important to scientists and, more importantly, seismologists about inferring what is going on inside the Earth. So everything that we know about what's going on inside the Earth is all inferred. Okay, we use seismic waves to study what's going on inside the Earth. So every time that an earthquake happens, which they're happening all the time, some of them just being, those 1s and 2s on the Richter scale, not these grand 7s and 8s that make the news. But they use how those seismic waves pass through the Earth to figure out what's going on inside there because we can't drill down there. It's too hot once we get to the mantle. We don't have equipment enough to drill through that much of the granite or basalt that is our continental and oceanic crust, so we have to use these seismic waves. How these seismic waves are used is very similar to if you've ever had an ultrasound done on your body. If you've had a sports injury, they may have put some gel around your knee or on your abdomen or on a shoulder, and then they use a wand, and that wand sends out ultrasonic waves that bounce off of soft tissue and everything and are received back and put a image on the screen. Seismic waves move through the Earth, much like those waves move through the body, bounce around and everything, and how they come out on the other side of the Earth gives us a picture of what's going on inside the Earth. So those seismic waves, as they cross through different layers of the Earth, they change direction, they change intensity, and that gives geologists some good information to work on. So the first thing that we really have to know and what they look at as they're looking at these seismic waves moving through the Earth is called refraction. And refraction occurs as seismic waves move through the different materials of the Earth. And as they hit a different material, they start to bend a little. They refract. So you've got a couple seismic waves going out. We've got this point up here. What is that point? That's the point where that strain energy is released, which is called the... So the seismic waves are then sent out. You get multiple seismic waves sent out in all directions. These first seismic waves travel exactly how we would imagine them to travel. They travel in this curved line because the Earth is curved and spinning. Whole different story. But it is traveling in a straight manner. Where if you look at this other seismic wave, again released right from that focus, right, as it hits this different layer of the Earth, there's a bending of that wave. And you can kind of see right here and right there where those seismic waves bend, ever so slightly. That's called refraction. So it continues to travel then through this other layer of the Earth, and again, as it changes layers, it refracts again, as evident by those 2 points. So refraction is those areas where the seismic waves bend. Another term that you need to know is called a discontinuity. And a discontinuity is where there's a boundary between two different layers of density. Okay, so your example here is if I had a beaker and I poured a bunch of water on here, and then on top of this beaker, I poured some oil in here. Okay, you would see these two clearly distinctive layers. The discontinuity would be that area right in between where those two layers meet. I could take this beaker, put a lid on it, shake it up. If I came back in 5 minutes, you would see these layers separated again, and you would have that discontinuity. So the discontinuity is that layer where there are a density difference, and it's that boundary. Okay, that's where that speed and direction of seismic waves changes. That's where that refraction happens that we just talked about. One of the most popular and the one that you need to know is the Mohoveric density and that or discontinuity, and that was in your readings from yesterday, so you should know where that Mohoveric discontinuity is and what is it the boundary of, what two layers of the earth. Another thing that we get because of refraction is shadow zones. And here we're coming into this area of P waves and S waves don't go through the same materials. So what states of matter do P waves go through? What states of matter do S waves go through? Hopefully you just answered those questions, that the P waves can go through solids and liquids, where S waves can only go through solids. So as soon as an S wave hits a layer of the earth that is solids, it is going to stop. There's not going to be any more seismic waves passing on through there. And as those seismic waves stop and hit these layers of the earth that are solid, they are going to create what we call shadow zones. So let's look at this image here. Okay, this is shadow zones produced by P waves and by S waves. This one here is the P wave one, and this one here is the S wave. Remember, P wave stands for primary, S wave stands for secondary. So your P waves, okay, go through solids and liquids. Okay, but what happens is at these density differences, at those discontinuities, you get that refraction. So we have some refraction going on here. And with that refraction, you get two areas where there are no P waves shown. So if this was where the focus was, the seismic P waves get spread out. They go out in all directions from that focus. You're going to get areas on the 2/3 of the way on the opposite side of the earth where there are no P waves recorded on seismograph stations. The complete opposite side of the earth, you're still receiving P waves because they are going through that core. S waves, on the other hand, okay, you've got your focus, same earthquake happening here. But now, as those S waves hit the liquid outer core, okay, they stop because S waves can only go through solids. They can't go through liquids. So they stop, and you get this large area where there are no S waves. Okay, again, P waves go through solids and liquids. S waves only go through solids. So as we take all this information, geologists have decided to divide the earth kind of up into two different systems. Okay, the first is the compositional, and this is based solely on what the layers of Earth are made of. So if they're made of the same thing, they are classified together. So these are the systems that you may have learned as a little child in science class: the crust, the mantle, and the core. Again, only based on what they're composed of, what's in there. Okay. The other way, which leads us to look at the Earth differently, is the structural layers. Okay, what are they actually doing? Here's the structure, what's the function? So we have these different layers. We have the lithosphere, the asthenosphere, the lower mantle, the outer core, and the inner core. Okay, so you get these different layers. The lithosphere, that's our tectonic plates. Okay, that's where those earthquakes are happening, because those lithospheric plates, okay, have that friction with each other. They get stuck, and then that tension, that energy builds up until it gets released. The asthenosphere, that's the layer of the Earth that the lithospheric plates are moving on top of. The asthenosphere is moving. The mantle, it's that extra part of the mantle that we know is structurally different than the asthenosphere. We know it's structurally different than the outer core, so it has its own classification. The outer core, we know that there's the outer core because of the composition. We know that it is liquid because the S waves don't pass through there. Okay? And then you have the inner core, and the inner core is solid. Okay? We know that because of how those seismic waves move. So everything that we know about this interior structural layers of the Earth, we find out because of those seismic waves. So what does this look like? And you guys probably have seen this image. This is the compositional layers and the structural layers. Here's your compositional layers over here. Okay, that's the layers of the Earth strictly classified on what they are made out of. So you've got your crust, really thin layer. You've got your mantle layer, which is made out of a different substance. And then you have your core made out of iron. Compare that to this other image, which is your structural layers. Okay, that is how the Earth actually functions. You've got that lithosphere, okay, that's your tectonic plates. You've got your asthenosphere, that's the layer of the Earth that the Earth is moving on, or that the lithosphere is moving on. You've got this lower mantle area, and then you have that liquid outer core and that solid inner core. Okay, please note, none of this is to scale on the structural layer. Okay, the compositional layer, however, is. We enlarge this so that we can really show you those different layers. Okay, hopefully all of this makes sense. If you have any questions, let me know. Otherwise, please be ready for lab tomorrow. Have a great day.